Hey everyone! Today, we're going to pull back the curtain on one of the most powerful tools hiding in your web browser, the Network tab. Seriously, learning how to use this is like getting a superpower, whether you're building websites, testing them, or just trying to figure out why something's broken. Let's get right into it.
Okay, picture this, because we've all been there. A user clicks a button on your website and crickets. Nothing happens. The page just sits there. Why? Well, this is our little mystery for today. Think of that broken button as the crime scene, and we're about to put on our detective hats. That's right, you are officially the detective on this case. And every good detective needs their toolkit. Luckily, yours is built right into your browser. We're talking about the DevTools, and specifically, our favorite little corner of it, the Network tab. This is where we are going to find all the clues. So, first things first, we can't solve the crime if we don't have our tools out. Let's go ahead and open up our digital toolkit. Don't worry, it's super easy.
You've basically got two main ways to do this. You can just right-click anywhere on the web page and hit Inspect. Simple. Or if you're a fan of keyboard shortcuts, just press F12 on Windows or Command plus Option plus I on a Mac. A panel will pop up, and all you have to do is look at the top and click on the tab that says Network. And boom, you're in. Now, this is a really important step, so listen up. The DevTools only records what's happening on the network while it's open. It's not a time machine. So with that Network tab visible, you need to make the crime happen again. Go ahead and click that broken button one more time. This is what's going to let our toolkit capture all the behind-the-scenes action. Okay, so you clicked the button, and now you probably see a whole bunch of stuff filling up the Network tab. It can look pretty overwhelming, right? You'll see images, scripts, CSS files, a ton of noise. But a good detective knows how to tune out the distractions and find the key piece of evidence. And here's how we do that. At the top of the Network panel, you'll see some filter buttons. The one we care about, the magic button for this investigation, is Fetch/XHR. Just give that a click. This tells DevTools to hide everything else and only show us the API calls. These are the real conversations your browser is having with the server. This is where the story is. With all the noise gone, one thing is probably going to jump right out at you. The color red. See, the Network tab color codes requests. The ones in black or gray, they were successful, no problem there. But any request highlighted in red, that means it failed. That, my friends, is our prime suspect. All right, we've found our suspect. We've isolated the failed request from the lineup. Now it's time to bring it into the interrogation room and get it to talk. Let's find out exactly what went wrong. To start the interrogation, all you have to do is click on that red failed request right there in the list. As soon as you click it, a new pane will open up on the side with all the juicy details about this failed conversation. Now, in this detail view, you'll see a few tabs. Headers gives you the technical stuff, like the web address it tried to talk to and the status code. Payload shows you exactly what information your browser tried to send, but the one we really want to check out, the place where we almost always find the confession, is the response tab. This is what the server tried to say back. And there it is, the smoking gun. Right there in the response tab, you'll often see a plain English error message. In this case, it's pretty clear. Invalid authentication token. We've cracked the case. The button didn't work because the server thinks the user isn't logged in correctly. Mystery solved. So we solved it. High fives all around. But a great detective doesn't just solve the case and walk away. They file a report so the problem can actually get fixed for good. We need to share what we found with the developers. And there's a perfect professional way to do this. Go back to that list of requests, find our red culprit, and right-click on it. Then, just hover your mouse over Copy. And from the menu that appears, choose Copy as curl. So what's this curl thing you just copied? Think of it like a perfect, reproducible snapshot of the crime. It's a command that a developer can paste directly into their own tools, and it will recreate the exact same failed request you just saw. It's the absolute best way to report a bug like this because it leaves no room for confusion. Okay, the case of the broken button is officially closed. But to really level up your skills and become a true pro, you need to understand the language of the Network tab. Let's do a quick breakdown of those main columns you see so you can diagnose any problem that comes your way. You'll mostly be looking at these 4 columns. First is status. That's the response code. 200 is good. That means success. 400s or 500s, that's an error. Next is type. This just tells you what kind of file it is, and it's what lets us filter for just the API calls. Then we have size. This is how much data was moved. If you see a really big number here, it could be slowing down your site. And finally, time.
This one's huge for performance. It tells you exactly how long a request took. It's the fastest way to spot a slow API.
And that's really it. You've just learned how to go from a confused user to a web detective. You know how to open your toolkit, how to filter for the right evidence, how to interrogate a suspect, and how to file a perfect report. So the only question left is, with this new power, what other web mysteries are you going to solve?